Okay guys, here is the second video for multiplying and dividing when we have scientific notation. Again, the calculator will get us all these answers. We're trying to get through the process without the help of the calculator, but you can always check using that. So a couple of things here. First, a key concept when we're talking about multiplying and dividing with scientific notation. We didn't do our exponent rules yet. That's actually a chapter before this. So something that's needed is if we have the same base, right, to some power, in this case with scientific notation, we're going to have a 10 to some power, 10 to some power. When you're multiplying them, you just add you keep the base the same and you add the exponents. So for example, if I had something like 10 to the 5th times 10 to the 6th, that would equal 10. That stays the same. I don't do 10 times 10 get 100. That stays the same, and I would just do 5 plus 6 and get 10 to the 11th. Okay, very important concept when we go through this. If you were dividing, if I had 10 to the 5th divided by 10 to the 6th, what that does is the base stays the same, and I just subtract from top to bottom. 5 minus 6, which equal 10 to the negative first power. Okay, so we're going to use those rules as we go through here. So they're very, very important concepts to know. So when we multiply and divide, so I think it's real easy. We're going to use these rules. So if I had 5 times 10 to the 3rd times 8 times 10 to the 6th, think about this. When we multiply, we can multiply in any order. So this is really the same thing as saying 5 times 8 times 10 to the 3rd times 10 to the 6th. Right? I could just, if I want to do that. Okay, I'm not distributing in. There's no plus sign here in the middle. It's just this times that. The parentheses really only show multiplication. They don't mean much else. So I just do 5 times 8 times 10 to the 3rd times 10 to the 6th. I multiply 5 times 8. I get 40. And then 10 to the 3rd times 10 to the 6th is 10 to the 3 plus 6, or 10 to the 9th. So 40 times 10 to the 9th. However, we always got to double check. That guy's not in scientific notation. My decimal point right now is here, which means I would move it over 9 places that way. But I got to move it one more spot over, so now I had to move it 10 places that way. 4 times 10 to the 10th power. Okay, another one. So unlike addition, where we had to have the same powers up here to add, that's not the case anymore. So this is why it's easier in my opinion. 5.1 times 10 to the negative 6 times 3.2 times 10 to the 4th. I could rearrange this as 5.1 times 3.2 times 10 to the negative 6 times 10 to the 4th. I multiply 5.1 times 3.2. I just did that on the side. Remember, when I multiply, I don't need to line up decimals. I just multiply like I normally would, and then just count 2 decimal places, move it over 2. So I get 16.32 times 10 to the negative 6 plus 4. Right, that's my rule. When the bases are the same, I'm multiplying. I just add them, which is negative 2. So I get 16.32 times 10 to the negative 2nd power. Again, that's not scientific notation. I have to move it over 2 places this way, right, based on what I have. So if I'm going to move it 1 place over here, now I only got to move it to the negative 1st power to get it back to where it was. 1.632 times 10 to the negative 1st power. All right, that's my multiplication. For division, you're going to be given a division problem, and I'm going to divide my numbers and divide my base 10s. So 8.4 divided by 2 times 10.8 divided by 10.3. Remember our rule for the when we're dividing, we keep the base the same, and I just do, and instead of adding them, I do 8 minus 3. Okay, it's always top minus the bottom, no matter what their signs are. And over here, 8.4 divided by 2, I just did the math. I get 4.2, and then times 10 to the 8 minus 3, which is 5th power. That's in scientific notation. I'm done. One that's a little bit more complicated. All right, I had 3.2 times 10 to the negative 4th over 5 times 10 to the negative 7th. So I do 3.2 divided by 5 times 10 to the negative 4th over 10 to the negative 7th. 3.2 divided by 5 is 0.64. And then 10 to the negative 4th over 10 to the negative 7th is 10 to the negative 4th minus negative 7, right? That ended up being just negative 4 minus negative 7, and we know the rule, we add the opposite, so that's why this ended up being 3. So it ended up being 10 to the 3rd power. Now, once again, this guy's not in scientific notation, so right now, the way it's written, I'd move it over 3 units to the right. So if I want to move it over 1 more unit to get it in scientific notation, I'd only have to move it 2 units to the right to get that guy in scientific notation. All right, so looking at some examples, if we look at 5, 6 from the reteach, see, let's look at number 5. It's 7.1 times 10 to the 8th times 3 times 10 to the 8th. And we just go ahead and multiply this out. So this just becomes 7.1 times 3 times 10 to the 8th times 10 to the 8th. Don't get this confused with addition. Even though these guys are the same, that's fine. We're multiplying now. So 7.1 times 3 is 3, and 21 is 21.3. So I'm going to get 21.3 times 10 to the 8 plus 8, which is 16. Which now, if I have to adjust this guy, I'd move it 16 units to the right, so I'm going to move it over one more unit, 2.13. So now I'd have to move it over 17 units to the right. There's my scientific notation. If we did number 6, you had 2 times 10 to the negative 5th power times 6.2 times 10 to the negative 3rd power. So I do 6.2 times 2. I'll do that on the side there. 6.2 times 2. Yeah, 2 times 2 is 4. I get 12. Move it over one place. 12.4. 10 to the negative 5th times 10 to the negative 3rd. So that's going to be 12.4 times 10. We add these guys, negative 5 plus 3, right? Because minus negative, negative 5 minus negative 3 becomes, add the opposite. I get negative 2, 10 to the negative 2nd. This guy is not in scientific notation, right? One digit here, not 2. So right now I'd move it 2 places over. So if I'm going to move it one more over, 1.24 times 10, think about that. Now I don't have to move it one place, right? 1, 2. I'm going to be negative 1 power. And then if we did a division, here's number 8 from that same page. 6 times 10 to the negative 2nd over 5 times 10 to the positive 5th. I just do 6 divided by 5, put my decimal point down, right? It doesn't go in, add my 0. That would be, oh, it does go in, sorry. It goes in 1 time. There's my 5, I get remainder 1, bring down the 0, and that goes in 2. That would be 10, no remainder, so 1.2. So this guy is going to get me 6 divided by 5, right? So I did 6 divided by 5 times 10 to the negative 2nd over 10 to the 5th. 6 divided by 5 is 1.2 times 10. Remember what we do when we are dividing, we add exponents. I think I just found the mistake I did in that earlier problem. I'm going to go back to it. This now I subtract and it becomes negative 2 minus 5, which is negative 7. So that would be negative 7. And that's already in scientific notation. Let me drop back here. I made a mistake on the previous example. I'm multiplying here, so I add these exponents. I apologize very much. These guys should be added together. So it's negative 5 plus negative 3, which is negative 8. So this should be it was 12. Let me restart then. So it was 12.4 times 10 to the negative 8th power, which means I'd move it 8 units that way. And I'm going to move it 1 unit over, so it's going to be 1.24 times 10 to the negative 7th. I do apologize for that, okay? So when we're multiplying, we add. When we are dividing, we subtract. I made that mistake there. Whoops, I think I lost you on my screen for a second. All right, and then last example would be number 9 from the reteach. If I had 2.7 times 10 to the 5th power. Notice how this one was written. It's written with a divided by sign here. It's the same thing as doing this. 2.7 times 10 to the 5th over 9 times 10 to the 6th. It means the same thing. So I do the same stuff. Divided by 9 times 10 to the 5th over 10 to the 6th. And 2.7 divided by 9. I put my decimal point down and it goes in 3, right? 27, 0. So 0.3 times 10 to the 5 minus 6, which is -1. So I'd move it 1 unit over, right, the way this is written, but it's not in scientific notation. I need to write this as 3.0, or 3, times 10. Think about that. Now I'd have to move it over 1, 2 to get back to that same one, so -2. Alrighty, so there we have it with our addition subtraction. Again, make sure you catch my error there in number 6. Go back and make sure you follow what I did there. I'm supposed to add those, not subtract them. Otherwise, check out the rest of the packet, all right, that you guys are doing. See what you can answer on there. I'll post the answer to this tomorrow. All right, and good luck with everything. Enjoy your weekend. We'll get back at it Monday.